Hello, and welcome to this online workshop on sample size planning. My name is Bob Calin-Jageman. I'm a professor of psychology at Dominican University and the director of the neuroscience program there. The goal of this workshop is to teach you how to answer the question, how much data do I need for my research project? Strangely, this is not often a point of emphasis in our scientific training. To take myself, for example, I was in grad school for 5 years, a postdoc for another 3, and during that time I took 5 different statistics courses at the graduate level. The topic of how much data to collect came up maybe 3 or 4 times. And even worse, much of what I was taught informally in the lab turned out to be wrong. Now that's pretty remarkable and pretty dangerous. You wouldn't get onto a plane with a pilot who didn't have a flight plan or had gone to a crappy flight school. So it seems a bit strange that we often charge right into experimentation with no real sense of where we're going or when it will end. That's a missed opportunity because with just a bit of initial planning, we can do research that is more fruitful and more reproducible. So in this workshop, we'll demystify sample size planning. I'm not myself a professional statistician. I'm a neuroscientist involved in an accidental career detour deep into the world of statistics. One advantage I hope I can bring to this workshop is to present the material clearly in a language that fellow bench scientists can understand without having to delve too deeply into statistical arcana. Here's an outline. First, I want to convince you that sample size planning really is an essential tool to have in your training. Second, and perhaps the most important, I want to illustrate how many of the most common approaches to sample size determination are actually quite dangerous to scientific validity. From there, we'll look at what to do, reviewing 3 major approaches, some models, and some resources for getting started. First, though, let's set some context. When do you need a sample size plan? Well, the answer depends on the assay or the technique you're using for your project. Some assays give fantastically clear and unequivocal results, things like binding assays. When you have qualitative results and essentially no variation from sample to sample, you don't really need to worry that much about a sample size plan. The general rule of independent triplicates will usually be A-OK. Other assays or approaches generate enormous amounts of data, way more than you might typically need for answering your research question. In these cases, we get darn close to sampling the entire population. Margins of errors can become infinitesimal. If your technique just naturally spews out an embarrassment of data, then you could probably also forego a sample size plan. Most techniques and assays, though, are somewhere in the middle. Results where you get at least some variation from sample to sample, so you really do have to worry about sampling error, but where you can't generate just gobs and gobs of data, and so you have to think very carefully about the sample size you're going to collect and how to best make that trade-off between the time and expense of collecting data and the uncertainty that you will have for your research question. Most labs have a range of different techniques. Sometimes they might have several in each of these categories, but I suspect that most labs have at least the majority of their techniques in this broad middle range where sample size planning really is useful and in some cases quite essential. So let's say that you will be using a technique in this zone. In the next section, we'll look at why it's so important to plan a sample size.